To just give a quick intro on our paper at KDD this year, MOS, Multi-Objective Optimization for Stable Rule Sets. And kind of the idea of this paper is we are interested in tree ensembles. So tree ensembles are like very powerful models that are commonly used in machine learning, and they continue to be state of the art on tabular data and tabular prediction tasks. And however, these models are very large and they're difficult to interpret. So it's like difficult to take a tree ensemble and understand how kind of the features contribute to the prediction. And our goal here is we want to extract interpretable models from tree ensembles. So one way to do so is you can represent a tree ensemble as kind of a collection of rules, where every single rule is basically kind of the path from the root node to leaf node of each tree. And the prediction of the tree ensemble is kind of an additive collection of these rules. And each of these rules is like a sequence of if-then statements that you can kind of read and understand what's going on in the data. And the idea here is you can kind of extract a small collection of these rules that may be able to fit the data well. And this is typically done where you assign a coefficient in front of every single rule, and then you kind of fit these coefficients with some sparsity constraints. Now, we're interested in kind of interpretability along three kind of broad dimensions. The first one being compactness. If you select too many rules, that's a hard to interpret model. Accuracy, the selected rules must fit the data well, and stability. So stability is interesting, right? Because like if you change your data and you refit your algorithm, you don't want to see drastically different results. For example, here we're applying our frame like a generic rule extraction framework to the census prediction problem, and the idea here is if you kind of change your data from X to X prime and you get drastically different rules that use different features, you won't really trust the interpretations from this model. So kind of just a broad overview of our framework, we consider this type of multi-objective optimization problem where you have a stability objective and an accuracy objective, and you constrain sparsity. And what we're interested in doing is kind of exploring the Pareto frontier between accuracy and stability and kind of finding interesting models.